Have you ever heard sound like this? I recorded this sound while enjoying my ride on a chairlift in a mountain range in Slovakia, and it was nothing like I'd ever heard before. Or was it? I had a suspicion, and after some research, my assumption was confirmed. The name of the phenomenon is acoustic dispersion. Now let's take a closer look at it. In the following parts of this video, we'll briefly talk about the physics of dispersion and how you can simulate it in Max for Live and Python. So let's jump right into it. Before we start, one caveat. Even though I'm not a physicist, I actually graduated in physics 20 years ago. And for that very reason, people tend to ask me physics-related questions. Now, here is the thing. If studying physics taught me anything, is that unless you are a field specialist, you know basically nothing. And you should politely decline those questions. So, for the same reason, we are only going to scratch the surface here, and I leave the rest to your own research. To discuss acoustic dispersion, let's first mention that sound is basically a wave propagating through a medium, such as air, water, or even solid materials, like a steel rope, which is exactly what I experienced. Dispersion is the effect that occurs when different frequencies of sound propagate at different speeds. You can construct any periodic signal using carefully chosen sinusoidal waves, as shown in this demonstration, by selecting the frequency, amplitude and phase of each sinusoid. You can achieve different characteristics in the resulting signal. This ability to break down sound into individual sinusoids, each with its own frequency, plays a crucial role in understanding dispersion. Now let's take a look at a simple sound composed of 4 different frequencies that form a localized wave pocket rather than a uniform periodic signal. In a non-dispersive environment, like air, this signal will maintain its shape as it propagates. But in a dispersive environment, look at what happens as the signal propagates. The signal stretches in time because its high frequencies travel faster than the lower ones. Take a listen. This is the original sound. And this is the dispersed sound. One more time. All of this fascinated me so much that I decided to simulate dispersion myself to see how I could transform any sound I want this way. Now, here is my second caveat. Please note, I didn't go the hard way by rigorously applying the math of dispersion and hoping it would sound as expected. That would have taken ages. Instead, I decided to simply time shift different frequencies of the sound the easiest possible way. And to make things even easier, I asked ChatGPT to help me with the Python script. After several iterations, it worked. The algorithm may not be physically accurate, but it creates the same effect I heard during my chairlift ride. So the goal was achieved. This view of the signal in Audacity is particularly useful because except time domain of the signal, it also shows frequency domain. If you remember, I told you that this is a wave pocket which consists of 4 primary frequencies. 1, 2, 3, 4. And as for the original signal, you can see that all the frequencies start at the same timestamp. Whereby in dispersed signal, the highest frequency starts first and the lowest frequency starts last. Let me show you one more example. Here you can see a sound of hi-hat. The first window displays the original signal. The second window is dispersed signal, where dispersion was achieved by manipulating of the signal in time domain. And the third window shows again dispersed signal, but here the dispersion was achieved by manipulating the signal in frequency domain. So let's give it a try. First listen to original signal. Now listen to the first approach to dispersion and second approach to dispersion. By the way, if you are interested in the Python scripts that I used, no problem, just let me know in the comments and I will share them. And finally, as promised, I will show you a dispersion audio effect in Max for Live, which I created for Ableton Live. Actually, I was inspired by a wonderful video by Cycling74, who are creator of Max. You can find the link to the video down in the description. And again, if you are interested in the plugin itself, just let me know in the comments and I will share it for free. So from the technical perspective, that would be all. And I believe I owe you one explanation. So the question is, what does dispersion has in common with the sound I recorded on the chairlift? And here is the explanation. So the sound was produced by the rope, by the steel rope of the cable transport, which was parallel to my chairlift transport. And the system was offline when I was riding the chairlift, and during my ride it was started. And probably there is a rope which is 2 kilometers, I believe it is 2 kilometers long. This rope got some kick from the system and the sound was propagated along this rope and dispersion occurred, and that was the sound that I heard. So that would be all, my friends. Thank you for your attention. And please, if you want to help my channel, subscribe and like my videos.